Good evening, students. Today's video lesson is on drawing Lewis structures. Lewis structures are very important in chemistry because they give us the precursor to showing us shapes of molecules, which in turn determine properties, which we'll get into in our next unit. So today, drawing Lewis structures, this is kind of our base building block of molecules, so we really need to make sure we understand them. And today we're talking about the easy ones, which is the ones that obey the octet rule. So our objective for today, at the end of this video, students will be able to draw Lewis structures that obey the octet rule, including charged and uncharged molecules. So today we'll see some charges as well, whether they're positive or negative. So let's just quickly go through the steps, and we'll revisit them each time we draw a Lewis structure, so don't worry if you don't get them right away. So our first step is always to add up the valence electrons. We're literally going to figure out how many valence electrons each atom has, and then add them up to get a total of electrons that we can place around the molecule. There's one little caveat here. If a molecule is charged, we're going to add electrons for every negative charge. So if we have a -1, we will add another electron. If it is a positively charged molecule, then, which makes it an ion, we'll separate or subtract electrons. Our second step is to draw the skeletal structure of a molecule using the least electronegative atom for the center except hydrogen. We are never going to have hydrogen in the middle because it is always going to be on the outside, or what is called terminal. Our third step is going to be to fill the valence shells of the terminal atoms by putting lone pairs on, and we'll see that when we do an example. Our last step is to fill the valence of the central atoms. If no electrons are left, we'll add double and triple bonds to fill those octets. So without any further ado, let's go ahead and get started. Our first example is carbon tetrachloride. Carbon tetrachloride, our first step is probably to figure out what is our formula of carbon tetrachloride. If you remember back to our naming days, carbon tetrachloride is CCl4. So we have 1 carbon and 4 Cls. So if we look up here, step 1, add our valence electrons. Carbon has 4 valence electrons because it is in group 14. We're going to take 4 times the 7 valence electrons of chlorine. Chlorine is in group 17, so it has 7 valence electrons. So we're going to take 4 plus 7 times 4, which is going to give us 32 electrons. So that was step 1. We're adding up our valence electrons. Our molecule was not charged in this case, so we don't have to worry about that one. So now we're ready to do our second step, which is draw the skeletal structure of a molecule using the least electronegative atom for the center. As far as electronegativity, remember that fluorine is our most electronegative element, so the closer they are to the fluorine, the more electronegative they are. So our central atom is going to be carbon. A helpful hint here is that oftentimes our first element listed is going to be our central atom. This won't always be true, but a lot of times it will be. So then we're going to place, to create our skeletal structure, we're going to place the 4 Cls all around the central atom. We're only going to have 1 central atom for right now, so that's what we've done. So that was step 2. Draw the skeletal structure of the molecule using the least electronegative atom. Our third step is where we fill the valence of the surrounding or the terminal atoms. And so right now we've placed 2, 4, 6, 8. If we're following along, we'll highlight them. 2, 4, 6, 8. We've placed 8 electrons. So we have 32 that we can place, so we're going to keep filling the valence shells of like chlorine and carbon, hopefully, but we're going to start with chlorine. So if we fill chlorine, this chlorine, that has now 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, and 32. We have filled the valence of our terminal atoms. So at this point, we've used all the electrons that we're able to, but we've also filled our terminal atoms. But now our fourth step says we're supposed to fill the valence of our central atoms, but we don't need to because carbon is already full because of these bonds right here are filling carbon's octet. They're not, please do not mistake them for double bonds. They are single bonds, but that's how they are full, so we're good to go there. So they're nice and full. I'm just going to redraw these so we do not get confused and think that we have double bonded there, because we have not. Okay, so that's drawing a Lewis structure. Let's continue with ammonium. Ammonium here is, first off, we got to figure out our formula. Ammonium is NH4 with a positive on it. So now we have one of those examples where we have a positive. So kind of going through the valence electrons, ammonium, or N, has 5, group 15. Hydrogen, there are 4 of those, and each hydrogen has 1 valence electron. And then for the plus, we're going to take away 1 electron because we've lost 1. So now we've got 5 plus 4 is 9, minus 1 gives us 8. So that was our first step, is finding our valence electrons. Our second step is to draw the skeletal structure. Remember, we're choosing the least electronegative unless it's hydrogen, and hydrogen always has to be terminal. Hydrogen always has to be out here on the edges because it can only have 2 electrons. So that's why hydrogen is out here on the edges. If we look here, we've now filled our hydrogen, and we've actually already covered step 4 as well, which is filling our valence of our central atom. There's one last thing that we need to do when we have a charged molecule, is we need to put it in brackets to show that we have a charge on it. So there we have ammonium. So let's jump down and do another one. Nitrate, this one's going to be a touch more difficult, but we should be able to get there, right? Nitrate is NO3 with a -1 charge. So if we add up our valence electrons, nitrogen has 5, oxygen, we have 3 of those, 6, and this time we're going to add 1 electron because of that negative charge. So we've got 5 plus 18, 23, this gives us 24. So if we look there, we've now got nitrogen in our center, we've got oxygen, oxygen, and another oxygen. So at this point, we have now placed 6 electrons, if we're counting 2, 4, 6, and we're ready to fill our octets of our non-central atoms, which would be our terminal ones. So 2, 4, 6, 8. Now we've got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. At this point, we have now filled our octets of our terminal atoms, and we're ready to do the last step, which is fill our octets of our central atom, but we're out of electrons. We've already used our 24 electrons. So this is where we go back and maybe double bond. So we're going to erase perhaps this guy right here. And now if I put a double bond there, now nitrogen has its 8 valence electrons, and oxygens do as well. And there we have it. We have our structure. Now there might be a small question here for you. Miss Griffith, why don't we draw the why didn't we double bond this guy or this guy? And that's going to come up when we talk about resonance. That's in a couple of days. So remember that question and hold on to it. But for right now, just roll with this one right here, and we'll talk about resonance in the next couple of days. All right? At this point, I want you to try one on your own. I want you to try carbon dioxide. I'm going to work it very slowly, but without discussion, so you hopefully have a chance to work it yourself. All right, good luck. So, how did you do? Did you come up with this molecule right here? Carbon dioxide with a double bonded C to each O? If you did, congrats, awesome. If not, go back and watch the video and see how it kind of came together. So, to wrap this up, do you feel more comfortable drawing Lewis structures? I hope so. And last but not least, our next video up is exceptions to octets. So not always will our substances obey the octet rule. And you'll see that in the next video. See you next time.